Good morning, everyone. Thank you for joining our session today for Afterstruct for Composite Analysis and Optimization. I'm the moderator for today. My name is Darius Badinelli, and we have our instructor being Andrew, and he's worked with a lot of the OEMs around Detroit area and also with some of the university teams here. Okay. All right. All right, everybody. Let's get started again. I believe there was some people couldn't hear me, so welcome. Good afternoon and good morning to everybody in attendance. My name is Darius Badinelli, and I'll be the moderator for today's session. Today, our instructor will be Andrew, and he is the application engineer that works with some OEMs around the Detroit area and also with some of the competitive teams in Michigan too. Before we get started, I just want to let everybody know that you'll be muted. If you do have a question, please use the question tab on the GoToWebinar, and I'll be watching that, and if there's something related to the immediate topic, I will pause Andrew so he can answer the question, or we'll wait till later when we have a question and answer session. We are recording this session, so everybody who signed up for it and in attendance will get a link to this in the email later today, and so you can also share with members on your team. We will have two really short polling questions at the end. One will be asking when would be a time to offer these during your next build of your car, so we can make sure we can align that up so we can get even more attendance. Also, the second question will be asking if you would like to receive more information about this session or other sessions that we had, and then somebody from your region will contact you to see if they can help you out with that or set up maybe some more detailed training with your team. One of the questions that is asked a lot, so we'll just get to it right now, how to get, or is there a student version of the products you'll be seeing today? And the answer is yes. If you go to our home page and you go to the Academia tab, there is an option there to receive the student version, the free version of it. All you need to do is order it. Even though it's free, you'll get some information of where you're at, your information about your computer, and you'll be then sent, once it's approved, the necessary license file and a link to download. So it's free, and it allows you to work on models, FEA models of 10,000 nodes. If you do use our Inspire product, that one does not have any model limitation to it. So let's get started, and we'll change over to Andrew here. So again, thank you, everybody, and I hope you enjoyed today's session.
Hello, everyone. My name is Andrew Stankovic, as Darius introduced me. Thank you very much, Darius. And basically today we're going to be covering composite analysis and composite optimization. So hold on one second here while I get my screen up. Okay, so today we'll be looking at a student example of a composite monocoque. And so we're going to be going through all the different ways to set up composite analysis and many of the different features within HyperMesh, OptiStruct, and HyperView for post-processing. So I just wanted to start off real quick with going over basically the two different types of composite modeling. So when you model a composite in OptiStruct, the main element type that we're going to be using are shell elements. And so there's two different methods of representing the composite material, and those are the zone-based modeling and the ply-based modeling. In zone-based modeling, you have a property card that represents each unique zone of composites. So within, you may have many plies that all overlap, and within regions where all of the plies are the same, you'll have what's called a zone, and you can see that here visualized with all the different colors. This method is the traditional method of modeling composites, and it's easier from the standpoint of a solver because you have individual property cards, but once you start making modifications and doing optimization, it gets a little bit more difficult, and on top of that, it's not very representative of a real-world type of laminate. So the other modeling method that we have is what's called ply-based modeling. So I'll turn on the composite layer view here, and I'll show you what ply-based modeling looks like. So in ply-based modeling, you're going to be looking at every individual ply as kind of its own property. And instead of realizing these zones that have similar properties, you're going to keep it all based on the ply. So you can see here when I zoom in, we have many thin plies here and some thicker plies, and you can see all these different plies layered. And if I go through and start isolating some of these plies, you'll see that these plies have a specific shape, and normally in zone-based modeling you'd have one zone which represents all of a specific area which has all of the same plies. And so in ply-based modeling, you're basically going through and keeping all the ply entities and just representing one card that kind of defines the entire laminate. And that's called our stack card, and you'll see it here underneath this laminate feature. And so basically that's the two kind of differences. In a ply-based modeling, you'll have many plies and one laminate card that will kind of tell you the order that all your plies stack up. And in the zone-based modeling, you'll end up with lots of properties, and each property is grouped to a separate set of elements. And so each one of these color zones has its own property card. And that gets a little bit difficult to manipulate when you're changing all these different plies, because you have to go through and update every single zone that uses a specific ply. So today we'll be working with analysis and optimization on a ply-based model, and it will be this model. And so just so you guys kind of understand the process, optimization with our Altair products is broken down into three main steps. The first step is going to be free size, and this is basically going to tell you where you need material and where you need thinner material, where you need thick material and where you need thin material. After you run a free size, what we'll do is start cutting up all these different layers into thinner layers and starting to realize actual ply shapes that would be manufacturable. From there, the last step is a shuffle optimization, which basically tells you which order to lay all your plies up. When you start out with a model, you're probably going to come and bring in some type of CAD from some other modeling software. And so we want you to get to a point where you have mid-surfaced your CAD and have a nice clean mesh on the part that you're going to be looking at. So today you can see we have that as our starting point, and we also have kind of the frame here as modeled as 1D elements with some rigid connectors attaching the two. So this is the model we'll be working with all day and kind of going through the whole process of what's involved with analysis. If you look, when I bring in my model, we have a couple of different components. Like I said, tubing, the monocoque, rigid connections, and then some insert plates. We also have some loads and single point constraints. And then we have our two load steps created. So right now, everything in this model is set up like our traditional linear static analysis, but we haven't actually created any material properties or plies for our composite layup. So in order to do that, all you have to do is we'll start with our materials.